Well, again, what's the derivative of this function? The derivative is 3x squared. Our definition of a derivative is that it is the slope of a line tangent to a curve at a point. So regardless of the constant term here, regardless of what we have as the constant term, each of these has the same derivative, 3x squared. So the slope of the line tangent to the curve at a point will be the same, and in fact we see that it's all 3. So when we take the integral, if I were to take the integral of 3x squared, and remember I have to put dx to identify what the input variable of my integral is, I would have 3 times x, and I would add 1 to the exponent and divide by the new exponent, plus c. That's the same thing as 3x cubed divided by 3 plus c, or simply x cubed plus c. And again, remember, this is our function, x cubed plus c. Okay, let's look at the next one. This next problem we did in class, and I just want to point out, go back and look at it. When it says solve the differential equation, we're asked to find the function that has, in this case, the second derivative as x to the negative 2/3 power. In order to find the function, remember the second derivative is the derivative of the first derivative, and the first derivative, of course, is the derivative of the function. So we've got to do this a couple of times. So we're going to first take the integral of the second derivative. We go through the same process we went through before, and we come up with the first derivative equals 3x to the 1/3 power plus c. Now we're given some information about the first derivative. When the input is 8, the output is 6. So if the input is 8, the output is 6, that would be 3 times 8 to the 1/3 plus c. The cube root of 8 is 2. So we end up with a constant term of 0, which means then that our first derivative is very simply stated as 3x to the 1/3 power. Now we're trying to get back to the original function. This is the derivative of our function, so we must do this again. That is, take the indefinite integral of our derivative, and we will get back to our function. When we solve that by doing our basic power rule here, we get that our function is 4x to the 4/3 plus c. But we are given some information again that states that when the input is 0, so is the output. So if the input is 0, the output is 0. So 4 times 0, going off of this again, 4 times 0 to the 4/3 plus c tells us that c then would have to be 0. 0 equals 0 plus c, c is equal to 0. So what is our function? Well, our function is 4x to the cube times the cube root of x. Now this means then, if we go through and do a check, that if we take the derivative of our function, we would look at 4x to the 4, oops, let's back up. Let's make sure we do this correctly here. 4 times the coefficient times the exponent, and then subtract 1 from the exponent. So we would have 16/3 x to the 4/3 minus 3/3, which is 1/3. Let's go back and check, because I realize that we have an error back here, and this is why we have to do a check. If this is true, then we should have gotten that same answer back here with our derivative. So let's go back and check what we have. If this is our derivative, then when we took the derivative of our function, we should have gotten the same thing, and obviously we don't. So let's go back and check what we have here. If we take the integral of this, we This is correct. We add 1 to the exponent, divide by the new exponent. The error, and maybe you had picked that up, and we just didn't have time to correct it in class, but the error is that when we divide by a fraction, we should multiply by the reciprocal. So that'd be 3/4, which means that we end up then with 9/4 x to the 4/3 power. Now, that isn't going to change a whole lot. C is still going to be 0, but we should have 9/4 here and 9/4 here. And so when I come down here and I have 9/4 times 4/3, my 4's would cancel, my 3 would come up there, and this then becomes my 3x to the 1/3. And does that match now? Yes, it does. Okay, again, it's so important to check the work. We can all, as you know, we can all be making some little mistakes. If this is the derivative of the function, okay, and we found out that the constant term is 0, so if this is the derivative of the function, then what is the second derivative? So we take the second derivative, and that means the derivative of the derivative, so 3 times the exponent, subtract 1 from the exponent, and we would end up with x to the negative 2/3 power. Now let's go back up to the very beginning. Is that where we started with our second derivative? X to the negative 2/3 power, and in fact it is. So it does check, and we had an error. Our function is not, as we had stated in class, our function is 9/4 x to the 4/3 power. So make sure you change your notes to reflect that. Okay, the next problem. I always like to be able to bring some problems to you that relate to your business major. So we have here the one, determine the profit function for the marginal profit function. Now remember, marginal profit is the derivative of profit. So this is our derivative. And then we have an initial condition, which means that when we have an input of 5, the profit of 5 units, or whatever 5 represents, would be $650. This is no different than the last problem saying solve the differential equation. We are in fact doing the same thing. We want to find the profit function from this. So to start that, again, we're going to take the indefinite integral of, and remember, you must put those parentheses in. If we do not put those parentheses around this quantity, we're actually saying take the derivative, or the integral of negative 40x, and then to that add 250, and that would not be the right answer. So we need to put parentheses there. Will you have a point off if you don't? Yes, you will, because you have written some improper math. And also don't forget that you need to write the differential dx there. So if we're going to do this, we'll just take this one term at a time. Remember that we start by adding 1 to the exponent and then divide by the new exponent. Move on to the next term, 250. That's the same as 250 x to the 0, so we do the same thing. Add 1 to the exponent, divide by the new exponent, plus c. What we have here now is equal to p of x, the profit function. So we have p of x equals negative 40x squared divided by 2 plus 250x plus c. We'll just do one bit of algebra here and make this negative 20x squared plus 250x plus c. Now we have this initial condition, so let's look at that. We know that when we have 5 units being manufactured and sold, that we end up with a profit of $650. So P of 5 is the same thing as negative 20, 5 squared, plus 250 times 5, plus C, and that has a value of 650. So if we expand all of this, we will come up with, this is negative 500. You can check my arithmetic. 25 squared times negative 20 plus 1,250 plus C is equal to 650. Let's make that a C. Plus C is equal to 650. If we do our arithmetic, C is equal to negative 100. So we are needing now to determine the profit function. So let's make sure we go back and do that. Our profit function, therefore, the profit function is negative 20x plus 250x minus 100. And that would be our answer. Okay, our next problem is another application problem. Talking about the rate of increase of the number of married couples, capital M, and that number we get is going to be in thousands, 1970 2005, and it tells us that that rate of increase is given by this. This is not the number of married couples, but this is how fast the number of married couples is increasing. We've got to pay attention. T is in time and years. T is equal to 0, corresponding to 1970. So we need to find the, we're given the information that in 2005, the number of married couples was 59,513,000. So let's see. First of all, in 2005, that corresponds to T is equal to 35 years since 1970. So T equals 35. M of T is our 59,500.